Okay, ladies and gentlemen, welcome to the second part of lesson number 11. In this lesson, we're going to continue our quest of learning the art of normalizing our database tables. In the last lesson, lesson 11, part 1, we learned about first normal form and some of the ideas behind normalization. Now, in this lesson, lesson 11, part 2, we are going to be diving into the remaining normalization strategy. So that's going to be second normal form and third normal form. So let's go ahead and dive right into the content. We need to move on to a more strict normal form, which is the second normal form, to make sure that we are free from all these anomalies. So like I said, the first normal form here will help with some of the anomalies, but it will not solve all of them. So we need to move on to the more strict form, which is the second normal form. So the rules of 2NF, second normal form, are that it must be in first normal form, it must meet the criteria of 1NF, and it must also have this. It must adhere to non-key attributes, must be dependent on the entire key. Okay, so the first rule is easy to understand because obviously you understand hopefully what first normal form is because we just talked about it. But what the heck does this second rule mean? So first let's define a non-key attribute. So a non-key attribute is a column in the table that is not part of not part of the key of the table. So again, a non-key attribute is any column in the table that is not part of the key of the table. So let's go back one slide just to illustrate that point. So what is the key of this table? Well, right now, the key of the table is student ID. So all the rest of them are non-key attributes. So student name, student address, and class enrolled are non-key attributes. This is a key attribute, student ID. These are non-key attributes. Okay, hopefully that makes it quite clear. So a non-key attribute is non-key attributes must be dependent on the entire key. So now that you understand what non-key attribute is, now we can sort of dive into what the heck the rest of this means. So let's talk about dependency. So a dependency exists when a value of one cell can be determined by the value of another. It sounds a bit complicated, but it's actually quite simple to understand. For example, we have student ID and student name. Student name is dependent on student ID. So this means that any given non-key attribute must be dependent on the entire key of the table. So again, let's go backwards and talk about dependencies. Let's go back one slide, and we can look at the fact that the student name, even in this case, the student address, is dependent on the student ID. So you see here, when the student ID is 1, we can say with certainty that the student name and the student address is going to be Trevor Page in Toronto. As well as when student ID is number 2, we can say with certainty that the name is going to be John Doe and the address is going to be Chicago, because both of these are dependent on the student ID key. And as well as these also, so student IDs 3, 4, and 5, although it's not as easy to understand or see that. It's much easier when you see it broken down into multiple rows, but that is a dependency. So student name and student address are dependent on the key of the table, which is student ID. Now, like I said, non-key attributes must be dependent on the entire key. So this means that we have a problem. So to make this table second normal form compliant, we must remove the columns that are not dependent on the entire key. So by process of elimination, what do you think, which column do you think is not dependent on the entire key? So hopefully you said the class enrolled. So as you can see, these two columns are dependent on the primary key, or on the key of the table. Trevor Page, student name and student address are dependent on the student ID, but class enrolled is not. We cannot say with certainty that if the student ID is 1, the class enrolled will be a certain value. Because you see it changes with every single different student ID value. So it's not, you can't accurately make that decision, so therefore the class enrolled is not dependent on the entire key. So we are in a situation where we need to make this 2NF compliant. So here's going to be the new actual database schema that does adhere to the second normal form. Okay, so let's take a look at what the heck just happened. So we have since we said that the class name, or the class enrolled rather, I changed the name of this by accident. This should say class enrolled, but I put class name, my apologies. So the class itself is going to be pulled out of the student table. So you see here we no longer have class enrolled in the student table. Instead, we have a separate table which we call class. Okay, so like I said, I have class name here. Probably would make more sense to say class enrolled, but in any case, I'm apparently sticking with my mistake here and going through it the whole way, so that's good. At least I'm consistent in my error. So now that the key of the student table, now the key of the student table will be student ID. Okay, so we've changed it, so we have student ID, student name, student address. So the key is student ID, so that still remains the same. And the key of the class table, we can define it as being a composite key. So it's made up of two different columns, which is going to be student ID and the class name. So therefore, this table here, the two of these together, we're going to call the key of the table. Okay, so that will mean that everything is second normal form compliant. Okay, because again, as long as we make these two columns here the key of this particular table, then that adheres to first normal form as well as second normal form, right? Because with second normal form, we can't have any columns that aren't dependent on the entire key. And if the key of this table was just student ID, then it would not adhere to second normal form. So we need to make sure that both of these columns are the key of this table. Therefore, we have no non-key attributes that are not dependent on the entire key of this table. Okay, it's kind of confusing stuff. I know your head might be spinning, but this is very important stuff to understand in terms of how we actually and why we actually go about breaking these tables up into smaller and smaller pieces, or rather, not necessarily. I guess they are overall smaller pieces, but obviously when they come back together, they're the same size more or less. But it's very important to know and understand why and the process behind why we break these tables apart. Okay, just so it doesn't seem very arbitrary, these are the rules that we follow and why we break up these tables. Okay, again, the goal of this is to get rid of the opportunity to have anomalies. Insertion, deletion, and update anomalies are bad. This is what we do to avoid those. Okay. So to spin your head a little bit more, if you haven't really followed along with this, we're going to spin it again, and we're going to go to third normal form. So the rules of the third normal form are that obviously it needs to be in second normal form, and there must be no transitive dependencies, which means that non-key attributes should only depend on the key and not other non-key attributes. Again, I'm sure your head's spinning here. So let's talk about what a transitive dependency is. So a transitive dependency is when a non-key attribute, so that is a column that is not part of the key. So when one of those is dependent on another column in the table that does not belong to the actual key of the table. So to illustrate this point, I'm going to take the table that we had, the example that we had, and expand on it a little bit. So now I'm going to make it have the full address information inside of the student table. So previously, we just had student ID, student name, and student address. Okay, those were the three columns. But now, I've broken up student address to be city, state, and zip code. All right, so now we've broken it up into these extra columns inside of this table. So now we can look and see that there actually is a transitive dependency. Okay, you probably can't see it just by looking at. If you can see the transitive dependency right now just by looking at it without me talking about the example, then good for you. You are probably way ahead of the game, so that's good. But if you're not, you're probably with the rest of the 99% of us who seeing this for the first time have no idea where the transitive dependency is. So remember, the transitive dependency is where any non-key attributes depend on other non-key attributes. So in this table, the key attribute is the student ID. So the non-key attributes are these four different columns. So what of these four can you see any one or two of these columns that are dependent on another one? Okay, let's move forward and take a look. A transitive dependency actually exists between city, state, and zip code. And that is the key. That's the case because city and state are dependent on zip code. Remember what I talked about, how I talked about dependencies? When you can say with certainty that a value in the table, or rather a column in the table, when you can say for certainty of what that column is going to be, what the value is going to be of that column based on the value of another column, that is a dependency. So, for example, if we know the zip code is, let's say, 90210, again, I'm from Canada, so this is the zip code that I always go to because we remember it from the TV show. In any case, you have 90210, we can say with certainty that the city and the state are going to be Beverly Hills, California, right? So that is a transitive dependency because in this particular table, city, state, and zip code are non-key attributes. They are not part of the key, which is student ID. These are non-key attributes, and two of the non-key attributes are dependent on another non-key attribute, which is called a transitive dependency. So because this is a transitive dependency, this violates the third normal form. So we have to pull the address information out of the student table. Let's take a look at that, what that would look like. So now we pull the address information out of the student table, which means we put it into its own address table. So now we've removed the transitive dependency, and we have a new table, like I said, called address. And the key of this address table would probably be student ID plus zip code. Okay, because if I didn't include the zip code inside of the key of this table, then we just have another transitive dependency, right? If this was just the key of the table, student ID, or rather if student ID was the key of the table, then again, we'd have a transitive dependency because city and state are dependent on zip code. So we include zip code as being the key of this table, and there we go. So now we've broken up our initial one table into three tables. And it's all using keys with the student ID pointing back to student ID foreign key pointing back to the I guess the parent table here with student ID and student name. So now do you see kind of what's happened here? What's resulted from all of these breaking apart of these tables? Now we have a student table which only contains information that's really pertinent to just the student, which is just the student's name. Okay, so it kind of makes sense. This is the student name, and that obviously is part of the student table. That makes sense. It fits in nicely with the sort of domain aspect, domain knowledge of this particular table, as well as the address table. All we have in here is information about the addresses, okay? There's no other information other than the foreign key, which is what we need to establish the relationship. But there's no other information. There's nothing about the class in here. We don't store the student name in here because we don't need to, because we have a pointer back to the student table with the student ID foreign key. All we have in here is the address information. Just like in the class table, all we have in here, other than the foreign key, is information that pertains directly to the class. Okay, so we sort of separated our concerns into different tables, which is perfect. That is what this is all about. So, phew, we're done. What have you learned in this lesson? So, you've learned that anomalies come in three forms, and they're bad for business. Insertion anomalies, update anomalies, and deletion anomalies. Normalization, the process of normalizing your database tables, is the answer to avoiding these anomalies. Normalization comes in three forms. Well, actually four forms, but three common ones are the first, second, and third normal forms. There's also the Boyce-Codd normal form, BCNF, but obviously I said I wasn't going to cover that today because it's very, very complex, and it's just sort of outside of the scope of what we're teaching today. And a database is said to be normalized if it satisfies the third normal form conditions. So remember, third normal form conditions includes the fact that it's second normal form compliant, and there are no transitive dependencies. Second normal form is said to be satisfied if you are in first normal form, so long as you're in first normal form, and any non-key attributes have to depend on the entire key of the table. And then you're said to be in first normal form if you're able to uniquely identify every single row in the database, and there are no groups. So there are no commas where you have multiple pieces of data stored in one cell of the database. Okay? Phew. So like I said, you probably want to go back and rewatch this video a few times if you didn't fully get all this stuff. But you're going to be seeing a lot of this as we go through the database course, especially this is all about design. This is database design 101 stuff, okay? This is how we make sure that we are free of anomalies, and we're always going to be applying these rules when we are creating our database tables. Cool? Cool. So, excellent stuff. Hopefully you grasped all that. I look forward to seeing you in the next lesson where we're going to start to talk about even more cool things related to database design. So, see you there.